Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework from section 9.2. In a random sample of males, it was found that 28 write with their left hands and 222 do not. In a random sample of females, it was found that 60 write with their left hands and 434 do not. Use a significance level of 0.01 significance level to test the claim that the rate of left-handedness among males is less than among females. If we consider the first sample to be males and the second sample to be females, then our claim is stated as P1 is less than P2. Now P1 is less than P2 only appears here, and it does in fact fall under the alternative hypothesis. So our H1, or our null and alternative hypothesis, should be selected as A. Next we want to find our test statistic, and so from here we're going to jump to StatCrunch. And you can go to Question Help and StatCrunch. I have my StatCrunch already open, and I also have stated my variables. So what we will do is we will go to Stat. We're going to do proportion statistics, and this time we're going to do a 2-sample proportion statistics with the summary information. And if we see that, the only thing we're going to need are the sample 1 successes and observations, sample 2 successes and observations. So if we take the males, x1, there's 28 males, and there's 250 total. I didn't make a big deal out of this, but they said 28 wrote with their left hands and 222 did not. But the total number needs to be added, the 222 plus the 28, so that turns out to be 250. And the same goes for the females. So the successes for females, the number of left-handed females, were 60, and that was a total out of 494. Alright, we're doing a hypothesis test, and for a 2-sample hypothesis test, we're always going to be comparing it to 0. And we also said that the males are going to be less than the females, and so we're going to use this less than symbol. Okay, we don't need to take a look at this, but let's take a look at the p-value plot as well. So let's run this, and then here are the results. We have the total counts of things. They give us information about the total counts, the count for 1, the total, count for 2, total, and then the sample difference and standard error. But this is what we really want, these two numbers. We want the test statistic, Z, and then we want the p-value, which is 0.353. Let's put this in. Our test statistic needs to be rounded off to 2 decimal places, so this is going to be a 3.8. And then our p-value is 0.353. So that looks like it's not going to be less than the significance level, so the p-value is greater than the significance level. And if it's greater than, then we fail to reject the null hypothesis. And whenever we fail to reject something, we're always going to say there is not sufficient evidence to either support or reject the claim. So in this case, we're looking at the claim. There's not sufficient evidence to support the claim that there's more left-handed. Okay. Next, they want us to construct a confidence interval. And notice at the 0.01 significance level, the confidence level that they're asking for is 98%. So these two numbers are equivalent because in our hypothesis test was a one-tail test. And so because it's a one-tailed test, we have to take that 0.01 significance level and put it on either side. In the hypothesis test, we just had it on one side, and that wasn't a big deal. But when we're doing confidence intervals are always two-tailed tests. So we're going to take 0.01 on the left and 0.01 on the right side, and that would leave us a confidence level of 98%. Okay, so let's go back to our StatCrunch. Oh, by the way, this is our plot, and notice there's a big red area, so we're failing to reject. Okay, let's do another statistic. This is a proportion with 2 samples with summary and the number of successes. Let's see if we can look that up again. 28 out of 250 for the men, and for the women it's 60 out of 494. Now, instead of a hypothesis test, this time we're doing a confidence interval, and remember our confidence interval went down to 98% confidence, and I guess we don't need that. Let's just do the computation, and here we have the lower and upper limits. So if they want to do a percentage, then we just have to remember to move the decimal place over. Let's see what they're looking for. They're not looking for a percent, so let's just get down the decimal, and they want this rounded off to 3 decimal places. So this is 4, this is 3 decimal places for that first one, negative 0.067, and in the upper limit, rounded off to 3 decimal places is going to be 0.048. 0.048, and then that's it. Okay, so it's important to note that one side of your confidence level is negative, the other side is positive. So the confidence limits do include 0, and so if they include 0, then they're probably about the same, about equal, because 0 is saying that there's no difference between them. So P1 minus P2 is equal to 0, saying that there's really that much difference. So it looks like it's saying that the men is supposed to be less, and it doesn't seem to support that. And that's going to be the same result as the hypothesis test. So based on the results, the left-handedness among males and females, the rate of left-handed among males does appear to be less. That's not true. That's not what we found. The rate of left-handed among males does not appear to be less than among females, so this is a good candidate for us. Let's read through the rest. The rate of left-handed males does appear. Nope, it does not. And there's inconclusive. Nope, that's not it either. So our answer is going to be B. They don't appear to be too different from each other. Alright, I hope that helps.